Hello everyone, welcome back to our channel. In today's video, we are going to discuss about the general space force system and its resultant. In the previous few videos, we have discussed about the resultant of concurrent force system and resultant of parallel force system. So it is very important to watch previous all the videos to understand this video because this is more complex video. So I request all of you to watch previous all the videos in this series and then you can come back to this video. So in this video we'll solve this numerical. A rectangular parallelepiped carried three forces as shown in figure. Reduce the force system to a resultant force applied at the origin and moment around the origin. So first you should find the resultant of the given force system and then find out the moment about the point O. Here the force present are F1, F2 and F3. F1, F2 and F3. Magnitudes were given. So we'll start with the force F1. Now we'll start with the representation of forces in the vector form. So first the force F1. So it is located here shown with the red line. So for this, see the arrow, it is moving from B to D. So initial point is B and final point is D. Now find out the coordinates of point B. Now this B is located on the Y and Z plane. See, this is the plane, YZ plane. So its X component will be 0. So X value is here 0. The Y value of point B is 4 meter and the Z value will be 3 meter. Both are positive. It is located on the YZ plane. So X value will be 0, X component will be 0, Y component will be 4 meter and Z component is 3 meter. Now see this point D, it is located on the XY plane. This is X and Y. So XY plane. So its Z value will be 0 and X value will be X component is this is X component. So it is 5 and the Y value will be 4 meter. So it has height 4 meter common everywhere. So this height is equal to 4 meter. So the components of D are 5, 4, 0. So you can note down this value because it is used in the next table. So F1, the magnitude of F1 is 200 Newton. See here 200 Newton is given. So it is equal to 200 Newton. The initial point for the force F1 is B and final point is D. Now write down the coordinates of D, 5, 4, 0 and for point B it is 0, 4, 3. Okay, write it properly. Final point above and initial point in the next line. Now do one thing, 5 minus 0 is equal to 0, 4 minus 4 is equal to 0, 0 minus 3 is equal to minus 3. So this is the value of A, this is the value of B and this is the value of C. So put it here, square root of 5 square plus 0 square plus minus 3 square. The answer is 5.831. In detail we have explained this part in previous few videos. I will not waste your time. So F1x is equal to the magnitude into A, that is 5 divided by this 5.831. The answer is 171.5. Next, to calculate the F1y, multiply the magnitude with B, that is 0 divided by 5.831. The answer is 0. Then multiply this magnitude to next term. So 200 into minus 3 divided by 5.831. The answer is minus 102.9. In the vector form, this can be written as 171.5i plus 0j minus 102.9k. Each color represent ijk term. We'll go to the force F2. Now F2 is located here. It is a vertical force. So directly you can write its vector form. But if you are confused, don't worry. The initial point of this F2 is E, as it is moving from E to D and the final point is D. Now the coordinates of point E are, it is located on the x-axis, so y and z coordinates are 0, only x coordinate is present. The x coordinate is 5 meter, so 5, 0, 0. D is located on the y-x plane and its values are already calculated, so its values are 5, 4, 0. Then see the magnitude is given 100 Newton, so we'll put those values in the table format. You can note down all the values. The F2 force, the value is 100 Newton, magnitude is 100 Newton, the initial point is E and final point is D. The d coordinates are already written here. Copy that, 5 4 0, and a value of E are 5 0 0. Then subtract the second row from the first. So 5 minus 5 is equal to 0, 4 minus 0 is equal to 4, and 0 minus 0 is equal to 0. So here we will write the square root of 0 square plus 4 square plus 0 square. So the answer is 4. Now we will find out the value of f2x. The f2x will be 100 into 0 divided by 4. The answer is 0. Then 100 into 4 divided by 4. The answer is 100. And then 100 into 0 divided by 4. The answer is 0. So in this way we get the component. So in vector form we can represent it as 0i plus 100j plus 0k. This is the vector form for the force F2. After this we'll go for the force F3. F3 is located here. So the starting point for the F3 is A and the final point is G. Now A is located on the Z axis. So its xy component will be 0, only it has the Z component. So the value of Z is 3 meter here. So coordinates are 0 0 3. The point G is located in between XYZ axis. So it has all three components. Okay, it is not located on a particular axis, or it is not located on any plane. So it is located in a three-dimensional space. So the value of G is X component will be X is equal to 5 meter, Y is equal to 4 meter, and Z is equal to 3 meters. So the 5 4 3 are the XYZ coordinates of point G. X is 5, Y is 4, and Z is 3. And the magnitude of force is 400 Newton. Put the values in the table. F3 magnitude is 400 Newton. The value of the initial point is A and the final point is G. The coordinates of point G are 5, 4, 3, and A are 0, 0, 3. Now subtract this second row from the first row. So 5 minus 0, it is 5. 4 minus 0, it is equal to 4, and 3 minus 3 is equal to 0. Now find out a square plus b square plus c square and its square root. So 6.403. To calculate f3x, what we will do? 400 into 5 divided by 6.403. The answer is 312.35. Then 400 into 4 divided by 6.403. The answer is 249.88. The next term will be 400 into 0 divided by 6.403. The answer is 0. So we can write the vector form of the given force is 312.35I plus 249.88J plus 0K. So in this way we have converted all the forces into the required vector form. We'll move on to the second table, that is resultant. So resultant is equal to F1 plus F2 plus F3, addition of all the forces. Now resultant is equal to, write down the vector form of each force, second force, and the last force. To find the resultant, what we'll do, we'll add the similar terms like terms related to the I. What are the terms related to I? 171.5, 0, and 312.35. Add them. Colors will help you to identify. The next term is J. Add 0, 100, and 249.88. This is the second term. And the last term is K. Add the green terms, minus 102.9 plus 0 plus 0. So this is the final term. So here we get the values as equal to 483.85I plus 349.88J minus 102.9K. Then the final unit of the resultant is Newton. Okay, so we can calculate the resultant if you know the vector form of each force given. Calculation of resultant will take the moment. So for calculation of the moment, the formula is very simple. Moment of a force about origin. Now why origin is considered here? Because it is given in the question that find the moment about the origin. That's why the O point is considered here, is equal to radius vector OB. Means connect this point O about which you are going to take the moment and the one point of the force, that is B. That's why ROB is mentioned here, into the force vector. Now here we consider the force F1. So what we will do, we will connect this point O with initial point of the force, that is B. That's why position vector ROB is calculated. The coordinates are already calculated here. For the origin, the coordinates points are 0, 0, 0. So here we have connected it, and this is the ROB value. Now to take the moment of force F2 about point O, we'll connect this point O with the initial point of F2, that is E. So here we get the vector, position vector ROE. So the formula becomes moment of force F2 about point O is equal to position vector OE into force F2. Then the third force is F3. It is moving from point A to point G. To take the moment about point O, we'll connect this point O with the initial point of the force, that is A. So here we get a position vector OA. So the formula is moment of force F3 about the origin is equal to position vector ROA into the force vector. So this will give you the value of the moment. You can note down all these equations properly because the equations are required for the calculation of next table. Now we'll calculate the position vector. The first position vector is ROB. So it is final point minus initial point. So the final point is B, initial point is O here. It is moving from O to B, so final point B, initial point O. Write down the coordinates of the points 0, 4, 3, 0, 0, 0. So first row minus second row, 0 minus 0, 0, 4 minus 0, 4, 3 minus 0, 3. So the position vector is 0i plus 4j plus 3k. Next position vector is ROE. Final point is E, initial point is O. So coordinates of E are 5, 0, 0 and coordinates of point O are 0, 0, 0. So first row minus second row, 5 minus 0 is 5, 0 minus 0 is 0 and 0 minus 0 0. So the position vector here is 5i plus 0j plus 0k. The next position vector is ROA. So final point is A, initial point is O. So write down here coordinates of point A are 0, 0, 3 and O are 0, 0, 0. So first row minus second row, 0 minus 0, 0, 0 minus 0, 0 and 3 minus 0, 3. Now the position vector is 0 plus 0 plus 3k. So calculate all the position vectors for the required vectors, then we'll find out the moment. Now moment of force F1 is equal to position vector ROB into the force. Now put the value of position vector ROB is equal to 0i plus 4j plus 3k cross product with the F1 171.5i plus 0j plus minus 102.9k. Okay, don't get confused by this cross product. You can use a calculator to do your works. So after doing the calculation, we get the value of moment as minus 411.6i plus 514.5j and minus 686 into k. The unit is Newton meter. Now we'll consider the force F2. For the force F2, equation is ROE into F2. If you are confused in the moment, you can rewatch the videos. In the previous few slides, we have discussed about how to find out the moment. Same position vector and the force is considered here. So values of ROE is 5i plus 0j plus 0k into the force is 0i plus 100j into 0k. Okay, just write down this value, put the values in the calculator and find the cross product. The cross product is 0i plus 0j plus 500k. The unit is Newton meter. To calculate the moment of the force F3, what we can do? Multiply the position vector OA with the force F3. The position vector OA is 0i plus 0j plus 3k into 312.35i plus 249.88j plus 0k. Take the cross product with the help of calculator. We get the moment value is equal to minus 749.64i plus 937.05j plus 0k. The unit is Newton meter. Calculate the moment for force 1, force 2 and force 3 by using the same method. Then last step will be resultant moment. Resultant moment is the addition of all the moments. So moment about O is equal to moment created by force F1 about O plus moment created by force F2 about O plus moment created by F3 about O. So addition of all these vectors. So to do the addition, we'll add the items first. Orange terms will be added first. Minus 411.6 plus 0 minus 749.64. So this is the item. Then add all J terms. Blue terms 514.5 plus 0 plus 937.05 J. And then add all green terms related to the K. Minus 686 plus 500 plus 0. So addition of all this term will give you the final moment about the O. So the moment about O is equal to minus 1161.24 I plus 1451.55 J minus 186 K. So this is how you can find out the moment and a resultant for the given general force system. You can find the location of the resultant by applying Varignon's theorem. So moment of a resultant is equal to summation of moment of all the forces. Here we can consider the resultant force act at some random point P, X, Y, Z, and we can take the moment of the resultant about that point, and we can find the components of x, y, z by solving the equation. We have already seen it in the previous example. You can watch that video. By following these 4 steps, we can analyze any general force system. In books, simplified steps were given, but these calculation in details were not given. So just follow this method, follow the table format. You will easily find answers without making any mistake. This method is solely designed for you to make this system very simple and less complex. I hope you find this video helpful. You can share this video with your friends. That will definitely help them to pass this subject. Please like this video and subscribe to our channel. Thank you. Thank you very much.